welcome to Mike Academy. So in this video, we are going to be looking at the Newton Raphson's method of numerical methods in engineering mathematics, and specifically, we are going to be using this question, log x minus 1.2, to explain that concept. Now, let's say we are given this question and we are asked to approximate the root of this equation, log x minus 1.2 equal to 0, using the Newton Raphson's method. Alright, so this means that my function f of x equals log x minus 1.2, and this is equal to 0. And in this case, our log is log to base 10 and not a natural logarithm. This is simply log to base 10 and not a natural logarithm. Okay, so let's take down our formula. Newton Raphson simply states xn plus 1 equals xn minus f of xn all over f prime of xn. Okay, so first thing first, we need to find our initial guess. So you remember, initial guess x naught is taken simply as a plus b divided by 2. So we look for two values such that when we plug them into this equation, one changes the value into positive and the other changes the value directly from positive into negative, and vice versa. Okay, so in this case, since this is log 10, it means that I am going to be taking my scale to be a very high value, because I can't choose 1, I can't choose 2, I can't choose 0, because log 0 is infinity. And remember, if I take log 10 will simply give me 1. And 1 minus 1.2 is a negative value, right? So which means we can take a scale of 10. So 10, 20, 30, and so on. So let's simply find f of 10. F of 10 becomes log 10 to base 10 minus 1.2, which is actually 1 minus 1.2, and this is negative 0.2. This value is negative. Next, we'll try f of 20. Okay, f of 20. This is going to be equal to log 20 to base 10 minus 1.2. So let's see what log 20 is. So log 20 is simply approximately 1.30 minus 1.2, and this will give us approximately 0.1, and this value is positive. So you see now that this the function changes directly from negative into positive. This is negative, please. From negative into positive when x is 10 and when x is 20. So this simply implies that my a is a value that causes the function to be positive, and that is 20, and my b is simply 10. Therefore, I can find my initial guess. S naught is equal to 10 plus 20 divided by 2, which implies that our initial guess S naught is 15. So x naught is simply going to be 15. So we start iterating. We'll find our first iteration starting from when n is equal to 0. So that becomes x1, because here is 0 plus 1. This now gives us x1 equals x and n is 0. That becomes x0 minus f of x0 all over f prime of x0. So which means we need to find the value of the function when x is simply what, x0, that's at x0. We need to find f of x0. We also need to find the derivative of that function and the value of the function at that same point, and the value of that derivative at that same point, right? So we need to find the derivative of this function. Okay, so if I find f prime of x, which means differentiating log x minus 1.2. So differentiating log x, we are simply going to have 1 all over x multiplied by ln 10. So this is actually using the change of base rule in differentiation to actually solve this. So you can and just to be clear, okay, just in case you want to know more, if y is equal to log x to base 10 and you're asked to differentiate, you need to first of all change log x to base 10. Now log x to base 10 is simply something as saying ln x all over ln 10. Okay, ln x all over ln 10. So this is simply the change of base formula, and if you employ this and differentiate, of course the denominator is a constant, ln 10 is a constant, but if I differentiate the numerator, which is ln x, I'm going to have 1 over x. So if you differentiate this formula, you're going to have x ln 10. So that's how we got this. So derivative of log x to base 10 is simply what, 1 all over x ln 10. All right. Okay, so that means f prime of x is simply 1 over x ln 10. Now let's find the value of the function f of x naught. This is going to be equal to, which means plug in the value of x naught there is simply what? 15. Okay, we got s naught as 15. Plug s naught into the function is log x minus 1.2. So we have log to base 10 of 15 minus 1.2. So I'm going to punch all this everything together just to save time. Do well to punch along with me to avoid any calculation error. So we punch log 15 minus 1.2. Log 15 minus 1.2. That gives us approximately negative 0.002, sorry, negative 0.0239. Okay, 0239 approximately. Next, we find f prime of x naught. This is going to be equal to 1 all over 15 times ln 10. So I'll punch everything all together. So I have 1 divided by 15 multiplies by ln 10. That gives us approximately 0.0290. So we have this. So let's plug to get our first root. This is going to be equal to x naught is known as 15 minus f of x naught. We have f of x naught as negative 0.0239. So we have negative 0.0239 divided by f prime of x naught, which is 0.0290. So we have divide 0.0290. So this simply implies that our first root x1 equals 15 minus, and this minus becomes positive. So let us find this ratio 0.0239 divided 0.0290. That gives us approximately 0.8241. Okay, sorry, 0.8241. Okay, let's take it to 4 decimal place. 0.8241. Okay, so if you add this up now, you simply find your first root x1 is going to be equal to 15 plus this gives us 15.8241. So we have our first root. Now, having found your first root, it means for the second iteration, x1 replaces the Newton Raphson formula. So that gives us x2 to be equal to, in the formula, this becomes now x1 plus, minus f of x1 all over f prime of x1. So this is going to be equal to, we know what x1 is, we just obtained the value 15.8241 minus, so let's find f of x1 and f prime of x1. So f of x1 simply means plugging the value of x1 into the function. F of x1 equals, function is log x, so this becomes log to base 10 of 15.8241, please. 8241 minus 1.2. So I'll punch everything all together. Do well to punch along with me. So we have log 15.8241 minus 1.2. That gives us negative 0.0007 approximately. Okay. So we find f prime of x1, which is going to be 1 all over 15.8241 multiplied by ln 10. So this is going to be equal to, let's find 1 divided by 15 multiplies 15.8241 multiplied by ln 10. That gives us approximately 0.0274. Okay, so we fall back here now. So for the ratio we have negative 0.0007, so minus negative 0.0007 divides by 0.0274. So divide 0.0274. So this means that x2 is going to be equal to 15.8421. Now minus times minus here becomes plus. So let us find 0.0007 divides 0.0274. That gives us approximately 0.0253. 5. So this simply implies that x2, which is the second root, is going to be equal to, let's now find 15.8421 plus 0.0255. That gives us approximately 15.8676. So we have this to be our second root. Now we find the third root via the third iteration. So for the third root now, x2 replaces the formula. So in place of x1, we now have x2 minus f of x2 all over f prime of x2. So this is equal to, we know the value of x2, 15.8676. So we have 15.8676 minus, let's now find the function f of x2 and f prime of x2. So f of x2 simply means plugging the value of x2 into the formula, so into the function. So we have log x, that becomes log 15.8676 to base 10 minus 1.2. So I'm going to be punching everything all together. So log 15.8676 minus 1.2. So this gives me 0.0005. So this is equal to 0.0005. Okay, approximately. Then we find f prime of x2. This is going to be 1 all over 15.8676 ln 10. So let's punch everything together. So we have 1 divided by 15.8676 multiplied by ln 10. This gives us approximately 0.0274. So we plug that now into the formula. So we're going to be having f of x naught give us 0.0005. So we have 0.0005 divides f prime of x naught give us 0.0274. So divide 0.0274. This means the third root x3 equals 15.8676 minus, so let's find this ratio now, 0.0005 divided 0.0274. That gives us approximately 0.0182. So this simply implies that our third root is going to be, let's now evaluate 15.8676 minus 0.0182. That gives us approximately 15.8494. Okay, so the root is still jumping, so we keep on iterating. Okay, so we'll go to the fourth iteration. X4 now becomes, so x3 now replaces the formula. I have x3 minus f of x3 all over f prime of x3. So this is going to be, we know the value of x3. x3 itself is 15.8494. 15.8494. So minus, let us find f of x3. Okay, we can do that here. So f of x3 is now going to be equal to, in place of x, we plug in the value as x of x3, which is 15.8494. So this becomes log 15.8494 to base 10 minus 1.2. So let's evaluate everything together. Log 15.8494 minus 1.2. So correct to 4 decimal place, this gives me approximately 0.0000, which is equivalent to 0. Next we find f prime of x3, which is going to be 1 all over 15.8494 ln 10. So let's find this and see. 1 divides 15.8494 multiplied by ln 10. This gives us once again 0.0274. Okay, so if you plug that into the formula, okay, for x3, the ratio becomes 0 divides 0.0274. So this means that x4 is going to now be equal to, we have 15.84794 0 divided by this remains 0, so minus 0. So this simply implies that the root of that equation x4 is equal to 15.8494. So you can see that this has repeated with the previous root, correct to 4 decimal place, and that becomes the answer to that given question. Okay, so the root of that question is simply 15.8494. All right, guys, so that's how to employ the Newton Raphson's method of numerical methods in engineering mathematics to solve log x minus 1.2. I'm sure you found this video very interesting and helpful. Please do well to like the video, comment nicely, share to your friends, and if you're new to the channel, do well to tap the subscribe button right now and turn on your notification bell so you don't miss out on the next video when it drops. I will see you in the next video. Thanks.